What happens when you get access to real production grade tools completely free? Can you actually build something meaningful with it? I had the same question. So instead of just exploring, I decided to build a complete real time system. And this is what I ended up creating: a real time flight anomaly detection system. A day ago, I came across Aiven Free Tier. They provide services like Apache Kafka, PostgreSQL, Valkey, and what really caught my attention was no credit card, no trial expiration, fully managed services. That made me curious. Can I actually build a real world system using this? So I tried. Let's understand the problem. In systems like aviation or IoT, data is generated continuously every second. For example, for flight, aircraft's altitude, speed, fuel level, engine status. And now the challenge is, how do we process this data instantly? How do we detect problems in real time? And how do we show it live on dashboard? So we are getting continuous data, how we can process this data instantly, how we detect the problems in the data real time, and how we show it on live dashboard. So I built a system that generates flight data, streams it in real time, detects anomalies, stores data, and shows everything live. An important note here, this uses synthetic data only, created for simulation. Let's quickly look at complete flow. Here are the FastAPI, Kafka, Kafka consumer, database, cache, WebSockets, and UI is the dashboard. First, the data is generated in FastAPI backend. So I'm using FastAPI to generate the data. So each record contains flight IDs, altitude, speed, fuel level, engine status. This runs continuously just like real sensors sending data. Now, this data is sent to Apache Kafka. Kafka works on something called publisher and subscriber model. Producer, we say like a producer that sends the data, consumer that reads the data. So here, FastAPI is the producer. Kafka topic is the data streams. Here we are streaming the data, and the consumer reads the data from that Kafka topic. So a Kafka topic is like a live data channel. All flight data goes into this topic, like complete flight data, so that we can topic name, and consumer listens to this topic and process data instantly. Now the consumer reads each message that we send to this Kafka topic. For every event, for each message, that means like that called as event. So for every event, it calculates a risk score. Example: low altitude, high risk; low altitude, risky; high speed, risky; engine failure, very risky; low fuel, risky. Based on these type of calculation, the system identifies anomalies like high risk or a warning signs, etc. After processing, data is stored in PostgreSQL. Why we need PostgreSQL? To keep history. Even though we are processing library, but for to keep history, we are storing the data in PostgreSQL for future analysis, for scalability. So now comes a key optimization. I use Valkey as cache because that is also one of the free services I'm getting from Aiven. So Valkey cache I am using here. Why cache? Because data queries are little slower. UI needs instant updates. So I store latest flight data and active alerts in cache. This makes data access extremely fast. So now the important part, how does UI gets real-time data? We use WebSockets. Normally UI calls APIs repeatedly that we call polling, but WebSockets creates a live connection. Once connected, server can push data at any time. So here how it works: UI connects to FastAPI via WebSocket. Backend listens for the new process. So this backend have also, once the data is processed, it also listens for the data, and when new data arrives, it pushes to the UI using WebSockets. UI updates instantly, no refresh needed because we are using the WebSockets. Now look at dashboard. Flights updating live. I think it's not updating live, so currently it is not running. Let me start running this. have documented every step here. So let's go. So this is the project. With this architecture, I have the source code, APIs, main and Kafka producer, consumers, Kafka consumer, db.py, cache.py, dashboard, index.html, certificates, Kafka and Postgres. These we get from the Aiven website for secure connection, and images, what are the required images, and .env, requirements.txt, and readme. So this .env, it stores all the secrets, uh, all the sensitive data. So these are the requirements. We have to create these services: Kafka services, PostgreSQL services, Valkey service. So how to create these services? This is very simple. Before we go into the code, let me see. Like here, we can just log in Aiven.io. That is the website of Aiven Cloud's service provider. We can come here, and then once we log in, so we can simply sign up. There is no credit card, no payment, nothing is required. Simply we can log in. I mean, we can sign up and then log in, and then we'll get uh, UI. You can create the services, click on here, and then you can select whatever the service that you want. If you want, like uh, for example, Apache Kafka, you can create Postgres, Valkey, whatever the things. It is very simple. Just come here, and we can, it will ask for the name of the service, Kafka service. Here we can select the free version, and then Asia Pacific, and then you can directly provide any name here, like whatever the name that you want, you can provide it here and create the service. Then you will get all the host details and the passwords, and also the CA certificate files, and everything will get, we can just copy paste into the code. So that's how, like, it's very simple. Now I will get service like this. So I have created Kafka arrow pulse. If you go inside topics, messages, I'm pushing the data is actually JSON. So currently 2532 messages from my past history. So currently the service is not running, so I will start the service. Before that, I just wanted to show like how their Aiven console looks. So like that, all these services, like whatever we want, we can create and we can keep it in one place. I have three services. One is PostgreSQL, Valkey, and this Kafka uh, service. So like this, like it will store all the data. So these are their services they are providing for the free of cost. That's why I'm very interested to do some project work on this. So I started there and built this small system, real-time system. So let's go here. Let me have provided every step in the readme file. You can follow and simply replace your values, and it should start new local. So let me start in here. I'm starting my app, FastAPI. It will start the FastAPI backend, and also let me start Kafka consumer. One is pushing the data to the Kafka, and also the FastAPI. Also, once the data is processed, then also it will collects the data and send to the UI using the WebSockets mechanism. And from the Cache also, it will take the data and push to the UI. So, and I'm also starting the Kafka consumer here already. This one is started. It is sending the batches, 5 flights data at a time. But we are storing in the Kafka as single event, like each flight has one record, single message. So this is how Kafka, this is consumer reading the data. You can see like a process. It is processed whatever the messages that we send from the producer. So consumer, this is the producer. We produce the messages, and consumer consumes those messages real time, and it do the processing, and it will update the UI. So now if you see, now the data is live. So flights updating live, risk scores changing, currently no alerts. If you see like this, and also alerts appearing instantly on the top, and graph moving continuously with the live data. So honestly, what made this more interesting was using Aiven, because setting up of Kafka, let's say like I want these type of real-time messages. If I want to set up Kafka in local, it takes more steps, like a little bit complex to do that, and also the database and caches. So all these building locally is complex, but here everything was ready, everything ready, all the things. and setup was very quick, no infrastructure headaches for all these services. That allowed me to focus purely on the system building. So I mostly focused on my core logic. This is the Python logic, just connecting to those cloud services. So I spent most of the time here. I directly used those cloud services. This started with curiosity for me. What I built with free real-time tools. So I built free of cost they are providing and used it here and showed in the real time. And it turned into a complete system. More than the project, I learned how real world architecture actually work. So if I see how so many messages should push from last few minutes because we have started the service now, it's see like 2627. Earlier it was 2500. So within minutes it's generated. It produced more messages and also processed and updating in real time. So as of now, we are using simulation data, like using the FastAPI, like we're generating synthetic data, but in real time, like we get the data from the IoT, sensors and other areas, and we can push to the Kafka, and we can directly analyze lively. So I have provided all the code and detailed information in the README file, and also have will also say the blog the details where I have updated clear steps. And before closing, I just want to show you what exactly is there. So here, if we see, we have the four different folders, four or five, I think, separately segregated. So here the API, in this API, this is where we start main.py. Here we are, this is the calculate risk. This is just a sample function that calculate the risk score based on the some if conditions, and this is the generate data. We are generating the data and send to Kafka. We are sending these data to the Kafka topic based on the Kafka topic name, and also we are also publishing this to the Redis cache, because Redis cache means Valkey, Aiven Valkey we are using as cache. So and it published to that particular cache system. Here R is, this is Valkey hosted. So it is also storing in that. And then we have the WebSocket. This, like here we have the publisher and subscriber concept. So it subscribes to that particular stream and then get the messages, and I think every 0.1 second it will do the uh, it will do the actions every 0.1 seconds. And also we have provided some small APIs like latest. This is from the latest data that we get from the uh, cache, Valkey cache, and this is where we are exposing the UI. What we are seeing here, fast API file response I'm using, and these are all some extra utilities. These are not directly useful, but whenever you want to do some reset DB or clear cache, so instead of manual, I can directly use those APIs. These are some extra things. So till here the major like main logic, and then I have the cache here. So this is just a cache, how we Redis instance creation and set the alerts and get the alerts. And the certificates, I downloaded these from the Avian website. Like when we create the services, they provide all the details then and there. We can simply go and download the required information. We can paste it here. Different certification files and the Kafka consumer. This is where like the consumer always listens to that particular Kafka topic and consumes the message and calculates the risk score and analyze the risk score and update to the system. And then like, and also we store it into the PostgreSQL for keeping the history. And then this is where we have the UI we built with HTML and also the JavaScript. Here we are fetching from the latest, that means it fetch from the cache for the and also here if you see, this is the WebSocket connection. So this we are providing some connection so that whenever the message are produced, the process data, then it will update to here instead of normal API calls. API calls is not that efficient when it comes to the real time because of there's some process delays. And this is the DB, the queries it contains, and the images. Here we store every sensitive data, secrets and other things. So now let's see, like it is running, right? So now we'll see how the messages, how many messages, 2627. Let me fetch it. Now 2787. So these are the real time it is processing, and also these are offset and partition, everything is there. And my dashboard is working on real time. So this is where I felt, when someone is providing the resources for the free of cost, let's use and spend some time and build your own system. Even though it is a small, it is totally fine, but try to build a real-time systems that gives some real world hands-on experience, and also a real world architecture, how it works, and you feel something that you have gained. So learn by doing. So learn by doing when you have the resources for free of cost. So I will share all the code and detailed readme file in the description. If you found this helpful, just like and comment. We'll see you in the next challenge. Thank you so much.